So, good evening, good evening, good evening. So, I'm back with another video. This time I'm going to be making a video called Restore IP Addresses in Leetcode. So, on the offset, this question looks somewhat difficult, but I can show you how to do it in somewhat of an easy manner. Alright, so this is mainly a backtracking question. If you think about it, so the one way to figure out it's a backtracking question is just look at the constraint. It's 1 to 20. So, that's not a lot. Alright, so let's look at the question. A valid IP address consists of exactly 4 integers separated by single dots, each integer between 0 to 255 inclusive. So you guys might have obviously seen IP addresses, right? It's that weird number that comes up when you try to hack someone's internet or something like that. So I mean, I'm just making that up. So in general, IP addresses are how you identify networks or other people's networks. So something unique about IP addresses is the way they look. So they are always 4 numbers separated by dots like this. Usually they are like this, something like this. So this is a class A address, and so usually I'm not too familiar with this. Like I have studied networks before, but yeah, it's these are IP addresses. So it's irrelevant to this question either way. The only thing you'll need to know about IP addresses in general are that they are consisting of 4 integers like this. Now these integers are always between 0 to 255. 255. And also one thing you have to know is that the first address can never be a 0. Alright? It should only be after that. Alright? So that's what we're going to do. So now what we're given is we're given a string, and we have to place these dots. Given a string S containing only digits, return all possible valid IP addresses that can be found by inserting dots into S. Alright, you're not allowed to reorder or remove any digits. Perfect. So we're given an integer like this, a string like this, and we are supposed to find out combinations by making IP addresses, and they should be complete. So for example, one possible way to do it would be to add a dot here. Then you cannot do this because 525 does not come in this range, 0 to 255 inclusive. So one way to do it in this case would be to put a dot here, to put a dot here, to put a dot here. So this is 255.255.111.35 inclusive. Perfect. So another way to do this would be to make this here. So 135 is a valid IP address, 11 is, 255 is, 255 is. So as you can see for this one, you have 2 valid IP addresses. So there will be no other combination where you can make it valid. So for example, if you thought of putting the dot here, this would be 1113, which is not a valid IP address. Similarly, you couldn't do one here because this won't be a valid IP address. Similarly, you cannot remove this and put it somewhere else because then 511 won't be an valid IP address. So that's how we have to solve this question. So let's begin solving this question. So like any other backtracking question, so usually when I think about questions like this where you have to validate across a huge number of possible combinations, permutations, etc., I would always suggest going for a backtracking approach. So let's define a function called backtracking. That's how we always start it. And what do we need in this backtracking function? So first things first, we'll need to keep track of the length that we are adding into this question. So we'll call that variable length. Alright. Then we'll also need to keep track, to a great extent, you'll also need to keep track of the word or the IP that is forming. So I would like to keep it in the form of an array because I think that that would be really useful. So if you have an array, we can put each individual element and then combine it at the ending to give you this perfect with the dot result. All right. And also one more thing that we need in this question is the dots, if you can see. So an IP address, you need it consists only of 4 parts. So we need to have 4 dots. So the initial one wouldn't really be a dot, but after you do this, we need to decrement it. So let's keep dots as one more of the variables that we need for the backtracking function, and now we're ready to go. So right now I'm just defining this function like this. Let's call the backtracking function with the parameter. So initially the length will be 0. You will have 4 dots that you can place an IP. So yeah, this question you can see 3 dots technically, but the first element is also a dot. You also have a dot before the first one if you think about it logically. You don't have to display the dot, but you have a dot before the first one. So anytime you encounter a dot, we reduce it, right? So if we have 4 dots here, we put this, reduce it to 3. Then we put this, reduce it to 2. We put this, reduce it to 1. Then we put this, reduce it to 0, and then we can start putting that entire string into the answer. Alright? So now, yeah. So what is this IP? This is an empty array initially. Alright? And we also need to keep an answer array where we'll keep track of all the answers, and we'll return this answer array after we call this backtracking function. Alright, so let's start with this backtracking function. So first things first, let's look at the edge cases. So the first edge cases is that if the number of dots that we have is equal to 0, so now you have exhausted all the possible dots, and the length is not equal to s, the length of the string. So you have exhausted all the dots, and you do not have any more, you have not reached the end of the string. So that means you're not able to use this entire string that they have given. So in this case, you have to return. So there's one more case where if you've reached the 0 dots, and in this case you do have reached the end of the string. So for that we have length is equal to len s. So now that in this case we will save this answer, we will save the IP address that we have gotten. So how are we going to save the IP address? We will append it to the answer, and the way we do it in this case is, so we will have an array of all possible combinations, somewhat like this. So you'll have 255, 255 dot, then you'll have 11, and you'll have a 135. So how do you get this output that you require from this? Well, it's very easy in Python. All you have to do is open apostrophes dot. So this is the variable that you want to join it with, dot join, and then you just pass in the array that you need, which is this one, which will contain this in the ending. Suppose you wanted to print this with commas and not dots. All you'll have to do is put a comma here. If you just wanted to join it without anything, all you'll have to do is this. And lastly, any variable that you have, you can join it with that here. So alright, so you have joined this here, and then you can return. Alright, so now let's actually do it. Okay, so now as you can see, we at max the number of elements that we can take here are only 3, right? So because anything more than 3 at that point, it's no longer a valid IP address, because it should be between 0 to 255. So how can we do that? So let's do it this way. Alright, for num in range 1 comma 4. So what does this do? So we will take the current value, whatever it is. We'll try at taking one element, we'll try taking 2 elements, we'll try taking 3 elements. That's why. So this range is inclusive, and within that range we'll try to backtrack with each of those values. Alright. So now let's check. So first thing that we have to do is if is valid. Alright. So is valid we have not defined yet. So let's assume there's an is valid function which we'll define, which will take in a string as a parameter, and it will return true or false. Whether it will return true or false whether the string is a valid string or not. Alright. So if is valid, now what do we have to take as the word? Well, it's very simple. We need to take the string. We need to start from the length, whatever we are at right now, up to length plus the number here. Alright, or I'll just call it I think it'll be easier if I call it I here. So length up to length plus I. So what would this do? Okay, I'll explain it in more detail. Alright, so suppose you start with 255, 255, 25. Let's start with the string, to this entire string here. What will it do? Alright, so first it will check from 0 to plus 1, right? So 0 to 1 inclusive, so it will take 2. It will call backtracking on 2, and then it will increase the length. So from in the next string onwards, we'll check from the rest of it. So if this does not end up being valid, we'll check with 25. Then we'll check with 255. After that, we'll exhaust this range, and it will stop using it anymore. I'll show it to you in the debugger as well. So if this is valid, what do we need? We need to first of all append it to the IP. Alright, IP dot append s of length. Okay, do one thing. Why don't I save this in a value? Alright, number, or let me just call it IP part is equal to this. Alright, So if is valid IP part, if this IP part is valid, if whichever part that we get it, if it's valid, we will append it to the array. Alright, after we append it to the array, we will call backtracking on it. Alright, so we'll call backtracking. So what do we need to pass now into this backtracking function? Now, since we have added this to the array, we'll have to do length plus 1. Since we're moving to the next element, remember, we've added a dot, so we'll have to reduce the dot. We'll have to reduce the dot. So we have only 3 dots remaining for the rest of the thing. Alright, so after that, what do we need to do? We need to also pass the new IP. So we have added this element to the IP. So now if this ends up not working, what do we need to do? We need to remove that last element from the IP. So yeah, this part is perfect. Now we're done with this part. Now all we have to do is we have to create this valid function that will check if it's a valid IP address or not. Alright, so one thing is there that if your string looks like this, 07. Is 07 a valid number? It's not. 7 is a valid number. There is no, in actual numeric system, there is no such number called 07. So we will have to take care of that turn case as well. Alright, so if the length of the word is greater than 1 and word of 0 is equal to a 0, we will return false. This is just a test for the cases where the word starts with 0. Suppose it's 09 or something like this, which does not work. But just 0 is a valid numerical. That's why I'm checking first if the length of the word is greater than 1. Alright, apart from this, let's check if the word is valid. Right? So first of all, it needs to be an empty string. Okay, if either of these cases, or if not word. Alright, so if you pass an empty string by any chance, then also it should return false. So if all these cases, it will return false. So now after this check, we can check if 0 less than equal to integer word, if the word less than equal to 255. If it comes within this range, we will return true, and we'll just return false in case it does not come match any of these criteria. Okay, so now we have passed the isValid word, we have defined the backtracking function, we've passed this, and now it will populate the answer array that we defined here, and it will return the answer. So let's run this. There's some issue. Let me just check what the issue is. Just a second. Am I calling it correctly? And start applying join IP. If just let me check here. If word and just a second. Okay, so I figured out what the issue was earlier. So the issue is that after just a second. Yeah. So the issue is that when you're calling the backtracking function the second time, one of the main things that you have to take into consideration is when you're passing the length. So once you take one element, for example, then you have to do length plus 1. But if you take two elements, then you have to do length plus 2. And if you take three elements, then you have to do length plus 3. So this is not length plus 1, this is length plus I. Yeah. Yep, now it works. So this I just did it to make sure. So let's run this problem. And yes, it's accepted and it beats 75% of the solution. So let me show you guys the debugger too, just to make sure. Apologies for that earlier, actually. I had coded this some time back. I had a small doubt within it, yeah. Yep, so let me show it to you guys in the debugger. So I'll just show you a little bit into it, how it goes, and then I'll show you guys the rest. Okay, actually this part I decided it was the earlier solution that I'd coded. Yeah. Alright, so let's do it. You begin backtracking from 04. Alright, so now the dots, these conditions don't matter. So yeah, now we'll start from 1. So it'll first take 01. So it'll take the string 2. So let's just keep track of the string that we have to take. So it'll take 2. So this is the string. And we are taking the part as 2. Alright. So now we'll first append it to the array. So now we have just 2 in the array. Now let's call backtracking for the rest of the elements. Alright. So now for the rest of the elements, and we've reduced the number of dots. Okay, so none of these conditions matter. So now we'll do it again with 1. Since it's coming back to the function, we'll check if the next element, which will be a 5 after that, is it true. So then we'll append it, backtrack, and then we'll have to do it again. So now we'll reduce the dots again. Now dots are 2. We'll do it again. So let's find the next 5. We'll add it and we'll decrease dots again. Alright, so now we have taken 2, 5, 5. So now we'll do it one last time, which will take the fourth 5, and we'll call backtracking again. So now as you can see in this case, we have taken the first 4 elements and now the dots have reduced to 0. We do not have any more dots to be placed. And we, and we have not reached, first of all, we have not reached the end of the string in this case. So since we have not done that, what we have to do is we have to return. We'll break from this loop. Okay, once you break, what happens? Why is this pop important? Now we'll remove this 2, the last 2 that we took. Now what is it going to do? We completed I in range 1. Now we have to do 2. So when we do 2, it will take 2 elements. So 2, 5, 5, it will take 2, 5 in this case. So it will take 2, 5, it will add 2, 5 to the element now. So like that, I'll tell you how it goes. So first it will take 2, 5, 5, 2 individually. Then it will take 2, 5, 5, 2, 5, yeah, like in this case, 2, 5, 5, 2, 5. Alright. After that, in the next case, it will take 2, 5, 5, 2, 5, 5. It'll take these 3. So now it's already exhausted 3. So now what will happen is, and we have not reached the end in either cases, so it will pop both of these. It will pop 5 and 2, 5. So you will be left with 2 and 5. After that, it will take in combination of 2. So it will take 5, 2, and then 5. Then it will take 5, 2, 5, then 5. And yeah, it will keep going like that, if you get my gist. So yeah, that's how we do this question. It's a backtracking question. It looks complicated from the offset, but it really isn't. So yep, thank you so much for watching, and I'll be uploading more videos.